Okay, so I'm gonna keep stalling for about another, minute or so, just to give everybody time to finish getting coffee and come on in. But in the meantime, I'm Jonathan Frankle. I'm Chief AI Scientist here at Databricks, and I run the AI research team. There are about 35 folks on my team these days, and my job is to, I can think of it a bunch of ways. One is that we're supposed to build models and exercise our products ideally beyond what any of our customers will do at any given time to push the limits so they're ready for you. We're supposed to do new science in service of building cooler products and more useful products for you. And I really think of ourselves as a bit of an internal OpenAI. My job is to be on the very cutting edge of Gen AI research, know the science backwards and forwards, run the experiments ourselves and have the data to serve you, our customers. We chat with customers all the time. We find ways to disseminate our knowledge. Ideally, our knowledge ends up in our products and you just get the benefit of it without even knowing that you're getting it. And that's really my day job. So in this very creatively titled talk, and yes, I thought about this title for hours and hours and hours to come to this brilliant conclusion, but this is the number one question I get whenever I chat with our customers, and in fact, whenever I chat with anyone. Gen AI is awesome. We have amazing, I'm really going to focus on text models, but amazing LLMs. We have amazing text and image models. We're getting more modalities every day. And we also have all these different ways of interacting with them. You can prompt a model. You can fine-tune a model. You can pre-train it. You can do RAG. When should you do what? I'm sure many folks here have heard of LoRa for fine-tuning. When should you do that? I'm sure people have heard of many-shot learning or what have you, in-context learning, all these different terms. What is this? And I'm sure many of you know what some of this stuff is or have a good intuition in your head. But also, when should you do what? So with that, I'm going to go ahead and dive in. So this is the most common question I get, just universally. Every single customer I talk to, every day when I talk to my team, when I talk to our product teams, when I talk to our engineers, when I have nice late-night conversations with our CEO, I still get the question, when do you do RAG? When do you do pre-training? When do you do fine-tuning? So, you're you or you're me, because this is a problem I have. I want to use Gen AI for my business. Should I prompt a model? Should I do RAG? Should I fine-tune a model? Should I pre-train my own model from scratch? And the answer is a little complicated, but my goal is by the time we're done with this session, you have an overview of kind of where to begin and how to think about this. When it comes to Gen AI, my best advice to everyone, and this goes above and beyond just this one question, is this is still a new field. We do not yet know all the rules of the game. This is not, physics where we have F equals ma and we have, laws of electromagnetism. We can generally reason about systems from first principles. This is still an open science. My job every day is to try to navigate this space when we don't know the rules of the road. But I think the important part to convey is there is science and there is reason behind this. There is method to the madness. But often my best advice is not precisely what you should do, but about process, how you should go about doing science and finding your way through this space. And I will say, one of my favorite things in the world is when a customer comes to me and it's time to pre-train. I love doing it because it's a hell of a lot of fun. You get to build your own ChatGPT quality model from scratch. It's an adventure. It's a huge amount of science. We have a blast. This is something that my team does every day just for our own work to push the limits. But it's not what everybody needs to do. And quite frankly, unless you're a very unique case, it's not where you should start. I would almost never recommend starting here unless you told me you were doing something for which no model could ever exist or has ever existed. You are building a protein model, and there is no protein llama. There's a code llama, there's normal llama, there's no protein llama. In that case, let's have a great conversation about pre-training. Otherwise, I would never recommend you begin here. As much fun as it is, as much as we can have a great adventure together and have a really good time, let's work our way up there. So this is a really hard question of when to do what. And I'm going to give you a cop-out answer in just a moment. I'm going to fess up to it. It's going to be a cop-out answer. But I promise I will take you on a journey that hopefully leads you somewhere useful. First of all, there is no one universal answer. And we don't even necessarily have rules of the road to tell you you've graduated from this stage to that stage, or you should do RAG but not fine-tuning. The other challenging part here is this is an ill-formed question. These aren't mutually exclusive. You can do many of these things together. And I'll give you some examples in a moment. But my answer is really, it's not about when should you do what, it's about the strategy. This is a design space. And I'll walk you through the design space, I'll structure it. And then what I'm hoping you'll take away from this is how to navigate that design space, what to try first, when to try what, under which circumstances, and how to work your way through it. That is, in my mind, the most important part. It's not about specifically do RAG but not do fine-tuning. It's about what order to try these things and how to work your way through them. So, just high-level principles to start, because it's always good to start with a few platitudes before we get concrete. Be data-driven. This is a science. You are scientists if you are doing this. If you've bothered to come to this talk and found your way all the way to the 3rd floor for a talk marked advanced, and you care about this question, you're a scientist. I never really understood what it meant to do data science until I started having to answer these questions, and then I realized, oh yeah, you're basically going into a lab with your data and a bunch of test tubes and a bunch of chemicals, and you are mixing them together and trying to see what happens and hoping nothing blows up in your face and hoping something interesting happens. That's really how I feel every day. And I think when I interact with customers, that's probably how many of you feel. You're just going around experimenting with these models. But again, we have the scientific method. There is method to the madness. The next and most important lesson, and if you come to my talk later today, you'll see a slide very similar to this. It turns out that the same themes come up again and again and again. Start small and work your way up. The deepest, darkest fear I have is someone who comes to me and says, hey, Jonathan, here's a gigantic amount of money. Let's pre-train a model from scratch on day 1. And usually my answer to you, if you were to come up to me and do this, and my salespeople hate me for this, is hell no. I won't do that with you yet. We need to work our way up to this. It's worth it to work your way up to it. And I'll talk to you about why in a few minutes. But it really is about starting small and working your way up. And then try things out and see what works. This is really an empirical science. So again, we've started with the platitudes, but the important part is do so in the right order. I'll give you the order, at least the order I recommend to folks. You're allowed to go on this journey in whatever order you like, but I have recommendations. Here's my strategy. This is how I do this every day in my work, how I advise my team to do it. And, really, I hope a lot of this advice you take seriously because I have to do this too. I'm not exempt. In fact, I have to do this and work my way all the way up to pre-training giant models. So I've gone on this journey again and again and again, and I go on it every day. Step 1, identify your measuring stick. You can't do science until you know how to measure what's good and what's not, what's better than something else. It sounds obvious and dumb to say, and I'm sure everybody here would give me the same advice if you were giving this presentation to me, but it merits saying because I see people who don't do this. I see people on my team who don't do this. I don't always do this. So I'm gonna, in some sense, do as I say, not as I always do, but I'll remind you, identify your measuring stick. If you don't have a measuring stick, there's no way to explore a design space and decide on the right choice. Number 2, you have to understand your constraints and costs. You have to know what matters to you and what your limitations are. And I'll talk to you concretely about this in a moment. But this is, now we're starting to outline the design space. We're constraining the solution space of where you can go. And number 3, explore that design space from cheapest to most expensive and track return on investment. This is a game of ROI. You don't just, arbitrarily spend money on a model without knowing whether you're getting value from it. You shouldn't do that. I would never recommend it. Again, I don't know if there are any salespeople who made it to this, but again, start small and work your way up. Go from cheapest to most expensive and track ROI. Identify when you hit diminishing returns and decide that it's time for a change in strategy. It's time to go back to the drawing board, or it's time to stop. Gen AI works amazingly well sometimes, and it's catastrophically disappointing other times. And I still don't fully understand when one happens and when the other happens. So you need to be open-minded to the fact that, it's not always going to be perfect, and there may be a point where you've kind of gotten as much as you can get out of it for your particular problem, for your particular data, for your particular metric on this particular day of the week. And it's possible an updated model comes out next week, and it feels like an updated model comes out literally every week. That may break open this problem again. So it's important to keep track of that. Knowing when to quit is just as important as knowing what order to go in. Okay, there's actually a step 0 here. I want to start with definitions because all these words get thrown around a lot. People define them in different ways. I'm not going to claim that these are the definitive definitions of any of these things, but I do want to at least give you working definitions that will hopefully be useful not only for this talk, but for the rest of the day ahead, because RAG, fine-tuning, pre-training, and all of that is going to be the order of business for many of these folks here, and certainly I'm looking forward to these presentations. So really, when we come to RAG, fine-tuning, pre-training, all these things, I actually think of these as two separate questions, or if you will, two orthogonal axes. The first one is, how are you interacting with the model? Suppose I hand you a model and I just say, this is your model. You're stuck with it. For better or for worse, come hell or high water, this is what I'm giving you. It's the only thing that your security department has approved, or the only thing that exists in the world. We've turned the clock back to 2021. This is what you got. Now, how do you interact with it? There are a lot of different ways. And I'm gonna give you kind of 3 or 4, but know that these are meant to just be kind of distinct points in the design space, and there are a lot more in between. First is prompting, and I'll go through examples of each of these. The next is kind of many-shot prompting, and I'll say more about what I mean by that. The next is RAG, or Retrieval Augmented Generation, everybody's favorite word of the day, and for good reason. It really works. Or some combination of these. These are not even mutually exclusive. You could combine, mix and match any of these. So here's how I like to do this. Rather than getting super technical, I like to keep it, simple example. This is prompting. Dear LLM, I wrote a Python program and received an error. Here's my program and my error message. Tell me what I did wrong and correct the program. Love, Jonathan. If you're talking this way to your LLM, different conversation. We can cross that bridge later. I will not recommend this as the ideal prompting strategy. Your mileage may vary, but we can be friendly with our models as well. So, okay, this is prompting. Now, this could work phenomenally well. If you were writing a relatively general purpose Python program, you're using libraries that the model has seen in its training data, an error that the model has seen before, good things can happen. But, let's make this a little more interesting. You're doing some kind of relatively niche task that the model potentially hasn't seen in the training data before. Maybe you need to give it a little more help and structure. This is what I would define as many-shot prompting. You can go everything from few-shot to, this could be 1,000 examples. One shot is just one example. And zero-shot, another way of referring to just simple prompting is zero-shot. The model has 0 examples. But now I'm adding in one little, part of my letter. I wrote a Python program and received an error. Here are examples of programs, errors, and corrections, ideally that are somewhat related to the one that I'm showing. I'm giving the model some examples here, something to kind of look at the structure of what I want. This can be really useful when you're looking for a specific format for the output of the model, because you're giving the model examples, and models are pretty good at mimicking formatting. Then we have instead RAG, and I'm going to say instead RAG for now, but again, these aren't mutually exclusive. So let's suppose that actually I'm using some internal library. You're writing Python code at work. You're going to use internal libraries. It's just a fact of life. And if Llama 3 knows about your internal libraries, it's worth chatting with your security department and having a conversation there. It probably doesn't. So you may need to give it some context. And in RAG, I'm not going to focus too much on the inner workings of RAG because you're going to hear about that a lot today. But the way to think about this is you take whatever prompt you're giving to the model, and you somehow have a database of other contextual information. This could be anything from just Wikipedia articles to your internal documentation to all of the documents that your company has in Databricks. And RAG is going up to those levels. And you have some way of identifying things that are similar. If you're using a particular library in your program, there's a way of identifying other documentation related to that library. I'm not going to dwell on ideas like embeddings and vector databases. I'll leave that for other folks later in the day. But the important part is somehow relevant data is being retrieved and handed to the model as additional context. It's not examples that look exactly like what you're doing, but it's relevant context. If you were asking, who was the first president of the United States, and you gave it Wikipedia as your database, it might pull up the article on George Washington or the article on US presidents. That's not the same format as your question, but it's context that the model can leverage in order to answer your question in a more factual way. That's how I think about RAG. Here are relevant parts of our internal documentation about the libraries that happen to be in here. Now, you could do both. I think this is a really important thing to say. This is not mutually exclusive. You can do both many-shot, where you're giving it multiple examples, and RAG, where you retrieve data. That's totally okay. Now, I mentioned before these are really two separate questions. First, I said, here is your model. You are stuck with this. But that is not the world we live in today. Go on to Hugging Face. You are not stuck with one model. Oftentimes, the problem is you're stuck with 10,000 models. And in fact, you can also build your own. So the other question is, where did you get this model? It could have been just off the shelf. You could have downloaded it from Hugging Face. And that's an awesome way to get a lot of really amazing models. You might have done fine-tuning. And I think of this as off the shelf, and then I trained it a little bit on some relevant data. And I'll talk more about what it means to have relevant data and how much is really fine-tuning. It could be continued pre-training. This is a term that I personally like Because one issue I have is people sometimes think if I took an off-the-shelf model and I trained it more, that's always fine-tuning. The problem is that there are many gradations of this, from I have 10 examples that I'm fine-tuning on to I have 10 billion examples that I'm fine-tuning on. Those are somewhat different situations in terms of cost and in terms of involvement. So I like to think of these, I like to try to draw some vague gradations in the space to say there's kind of little fine-tuning and much bigger fine-tuning, and eventually we get to a point where you're basically pre-training. And then there's full-on pre-training. I did not download a model from Hugging Face. I built the model that I could have put on Hugging Face. And again, I have a hell of a lot of fun doing this, but it's not the place I would ever recommend starting unless you're in a very unique scenario. So here's another way that I look at pre-training and fine-tuning. I think of this, these bars are meant to capture kind of amount of computation, amount of data, amount of involvement and work, and amount of cost. And so pre-training, DBRX, which is a model that my team built recently, I'm not going to claim it as the end-all be-all of models. It's one among many, but it's one that I know really well. We pre-trained it on 12 trillion tokens. That is a hell of a lot of data. Many enterprises actually have data on that order of magnitude. I think many folks in this audience would be surprised how much data they have at their company. It could be on the scale of the web. And then fine-tuning could be as little as 100 to 1,000 examples. So very, very different in terms of scale. If I were to actually scale these bars properly, you wouldn't even be able to see number 2 because it would be so tiny. And so in practice, if you were fine-tuning Llama, number 1 is just Meta did the work of pre-training it. They put in the cost. They thought about this very carefully. And you downloaded it from Hugging Face and fine-tuned it. Now, continued pre-training, I kind of think of this as like, bigger fine-tuning in some sense. You took that model that was downloaded from Hugging Face, and maybe we're talking 1 to 100 billion tokens of relevant data that maybe you pulled from open source data sets combined with your internal data. This is where we start to get a little bit more into the higher levels of involvement. And then you can still do fine-tuning on top of that if you want to, even more specifically. And we could add more phases here. When we train DBRX, there are actually 4 phases to training. And we've thought about adding more. So this can be iterative, and you can kind of start anywhere and make this more and more involved. Okay, we still haven't even gotten to step 1. So I want to start with evaluation. Not immediately relevant to the subject matter here, but I just want to rub it in your face a little bit and remind you, because I need to be reminded every day as well. You need to identify your measuring stick. So here's how I think about evaluation personally when I talk to my team. There are really 3 kinds of evaluations you need. One is you need something really cheap and automatic. The next is you need something somewhat more involved and a little more realistic that kind of bridges this gap. And then something close to the real world that is slow and expensive. You might do this once a month, once a quarter. You might only do this with A/B testing in production, but something that really says to you, I have moved the needle in practice. The first 2 are proxy metrics. They're meant to give you some signal. And what's the phrase? All models are wrong, some models are useful. That's kind of how I think of these first 2. And the last one should be like, okay, let's be right, but it's going to take time and be expensive. So for something cheap and automatic, I think of this as your inner development loop. You should be able to run this like many times a day. You should be able to push a button. This is like unit testing. You don't check in code without unit testing it. You don't iterate on your model without running this eval. It has right and wrong answers ideally so that you can get a really quick check. But as you know with generative models, nothing in the real world has right and wrong answers. So this is going to be a proxy. It's not going to be the end-all be-all, and you have to be really careful about knowing that difference. The next is something a little more involved and realistic. Ideally, the model does something generative if your task is generative, and you're likely going to use LLM as a judge. I'm not the world's biggest fan of LLM as a judge, but then again, there are many things in deep learning that we do that are not perfect, but seem to work really well. And if I knew something better, I'd tell you. So this is what my team uses. This works okay in practice. But we start to get in the realm of things where there are many right answers, and things are a little bit subjective. And then something close to the real world. If you're deploying this in a real setting, you're testing this with real humans. It might be that you have a pool of humans you beta test this on. It might be that you slowly A/B test this in production. Whatever it is, you're getting really close to your real workflow, and you might even do the expensive task of paying humans to check the outputs. This matters because this is the real metric. This is what you're really testing for. And those first 2 are going to be helpful, but if you're not moving the needle here, then you're not really moving the needle in general. Okay, that's evaluation. Step 2 is objectives. Understanding the constraints of your design space. So you need to know your non-negotiables. And here's the way I think about this. There are really 2 axes that matter, quality and cost. Quality we just talked about. That is your metrics, all the way up to what you're deploying in practice. Cost is complicated. Cost is fun. I could probably give you a 3-hour lecture on cost and all the 5-dimensional trade-offs in cost. I'm going to really simplify and water down because you just have to in practice. You can't keep track of 5 dimensions of cost all at once, as much as it would be fun if we lived in a 5-dimensional space. So one form of cost is just money. How much money is it going to take to create a model in the first place? Maybe it's $0 because you're downloading it from Hugging Face. Maybe it's way more than that because you're building it from scratch. And then how much money does it cost to use it? What is your inference cost? How much do you need to pay for the GPUs to serve this thing? The next one is speed. We live in a really competitive market right now. I certainly feel that competitive pressure every day. If I had released DBRX a month later, it probably wouldn't have been the best open source model when it came out because Llama 3 came out. And between those 2 releases, 5 other really amazing open source models came out from folks like Cohere and AI21 and other folks. So this is a competitive space for me. I'm sure everybody's feeling the heat right now. Everybody's trying to get AI. The time to create the system matters. Then there's also speed to use it. If you're doing a real-time chatbot, you can't wait around for 2 minutes for the model to generate a response. And people love watching text kind of blow across the screen. So that UX matters. And speed could then be measured in a bunch of other metrics. We could be talking throughput, latency. There's all sorts of other stuff. I'm not going to worry too much about the details here for now because I think you can instantiate all of this for your use case. But I do want to just highlight that this is complicated. So here's how I think about the world. This is, if you were to open up my brain and take a look inside, you'll just see a bunch of Pareto curves. So I love Pareto frontiers because we live in a world of trade-offs. Everything about Gen AI is trade-offs. On the x-axis here, I'm showing you cost, from cheapest to most expensive. And this could be cost to create the system, this could be cost to serve the system, and this could be any one of these costs. I put dollar signs here, but it could be speed. And on the y-axis is quality. And quality, I'm assuming, let's imagine we have your gold standard metric that captures everything you care about for the model. Obviously, it's not that simple in practice, but this gives us some idea of what's going on. And usually, in anything in the real world, you are going to see a curve like this. You pay more, you get more. That's just kind of one of those facts of life. You pay more you pay more for a plumber, you're probably going to get a better quality job. You pay more for a fancy restaurant up to a certain point, you might get a better meal, but in New York, you never know. I'm from New York. So it is all trade-offs. And so in this case, I'm going to actually instantiate this. On the x-axis, inference speed and cost. This is just one example. On the y-axis, MMLU. This is just a popular benchmark. And I'm going to put 2 models on here. Llama 3 7dB and Llama 3 8B. I think this is pretty intuitive. Smaller models are faster and easier and cheaper to work with. Bigger models, especially for this family, are better. This isn't universally true. Llama 3 8B is better than a lot of 70B models from yesteryear. So again, you need to be very careful about this. You could imagine putting points all over this, and there's going to be kind of the best points at any given trade-off. We're not going to worry about efficient frontiers or anything like that. Just think of this as a trade-off space. But I think most people here would argue that on most metrics, Llama 3 70B is probably a little bit slower and a little bit more expensive to serve and a little bit better than Llama 3 8B. And that's okay. These are different points in the space. So I want to go through 3 scenarios that I tend to see in practice when people are thinking about cost and constraints. And these are scenarios that come up all the time with customers. I kind of bucket you when I talk to you into okay, which one are you? So number 1 is AI is a step function improvement for you. You hope AI will allow you to do something you could never do before. This could be I'm thinking of things like AlphaFold. We just couldn't do protein folding. And now we can do it. And protein folding is such a valuable, beneficial thing for the world that we'll almost pay any price to be able to make progress on this problem. We are getting from 0 to 1 on some problem. And for a lot of folks here, you're basically getting there. Or something would have been so expensive to do with human labor, and now suddenly AI has made that so much less expensive that you can actually contemplate doing it. Something that would have been ridiculously inefficient and unthinkable is now thinkable. You'll pay almost any price for a way to solve this problem because the value is so extraordinary for you, for society, what have you. And so the way that I would frame this in terms of Pareto curves is you basically want to make quality as high as possible, almost irrespective of cost. Maybe you're not spending $10 billion, but within your budget in the context of your business, you're willing to spend a lot on this because it matters so much. And I basically think of this as that yellow arrow up there. You're just trying to get up and to the right. And really, as far up as you can, but the ironclad law of Pareto curves is you're probably going to have to go up and to the right. Getting better quality is going to get more expensive. That tends to be a fact of life in most things. Here's another scenario I see. It just needs to be good enough. There is some metric for good enough. It might be 99.999% accuracy, but there's somewhere where you say, okay, this is good enough. And after that, just make it cheap. If AI can't reach a certain level of quality, you can't use it. I'm sure lots of folks have this experience. If it's not good enough, it's not even going to make it into production. But once it reaches that level of quality, you're happy, and then it's just about like drive down the cost, drive down the, how slow it is, and just make it really, fast and easy to use. So minimize money, subject to reaching a certain level of quality. Here's how I would represent this here. I've drawn a horizontal line at whatever level of quality you wanted. Quality cannot go below that line. Otherwise, you want to move as far to the left as possible. And you can look at the point where the orange curve intersects with that yellow curve, and that's basically the optimal point that you can possibly hit. That's what you're going for. Now, you don't know a priori where this is. You're going to have to figure that out. But this is kind of what you're going for. The other way to think about this is you're on a budget, and that budget could be a lot of things. You have a certain amount of money, and you just want the best possible model. Or your model needs to be really fast and responsive for your users. You can't afford to go beyond a certain level of latency or a certain amount of throughput. I see this all the time in real-time applications. So make quality as high as possible, but only up to a certain cost. And this is how I'd look at it. I've drawn a line on cost. That is my line in the sand. We cannot cross it. But I want to make quality as high as possible. And again, the intersection between the yellow line and that orange curve, that's that's the ideal point I'm going for, but I don't necessarily know where it is immediately. So what strategy should I take? Start small and work your way up. Again, I've said it once. You're going to hear me if you come to my other talk say that like 15 more times. If you were to just remember only one thing, start small and work your way up. Start with things that are quick, easy, and cheap. Work your way into slower, harder, more expensive things. And I'll give you an example here. If AI is a step function improvement, carefully explore whether it's possible to meet your quality bar by working your way up. If AI just needs to be good enough, work your way up so you can find the minimal model that gets you to your quality goal. If you're on a budget, work your way up to the best thing that fits within your budget. Okay, so solutions. This has been like almost half an hour of me just doing framing and strategy. Again, that's the best thing I have to offer you. But what are the steps on the ladder? What is the design space you're climbing? Here's the ladder as I see it. If we're talking about where did you get the model, I kind of think of this as the rungs you should climb. Start with an off-the-shelf model. Start with calling the GPT-4 API. Start with calling a Llama 3 API from Databricks' Mosaic AI inference product. That's totally fine. Just start with that and then work your way up. Then we can talk about fine-tuning. If you're not getting what you need, or you are getting what you need, and you think that you want to put in more investment and get even more out of this, let's go to fine-tuning. If you're still getting ROI, let's go to continued pre-training, CPT. If you're really getting ROI and you're ready to have fun with me, and for anyone who does pre-training, you're probably going to hang out with me a decent bit, and that's fun. Let's talk about pre-training. And I think of this as working your way up in a number of different axes. For an off-the-shelf model, you could probably sit down with no background and just get a model that you can give inputs and outputs to through an API or downloading something from Hugging Face in hours. You could go to a demo session today and do this today. Fine-tuning is going to take days. There's a little bit more work in preparing your data set. It takes a little longer for each run. The runs may take on the order of a few hours. You may make a couple of mistakes. Continued pre-training, it's now weeks. You need more data, and it's more demanding, and the training takes longer. And then pre-training, it's really going to be a weeks or months engagement. This is, we're talking big things where you've really figured out that you know what you need, and now let's go build it. But it's also cost. You can call an API for pennies. If we're talking pre-training, I've got $6 signs up here. It is expensive, but the ROI can be there, and there are a lot of folks who use this service. It's not for everybody, and it's definitely not for everybody immediately, but I think for a lot of people in this room, you'll get there. And, here's another way to think about this. And this is really, I think, the other reason why you should start small and work your way up. This is a maturity ladder as well. The time to a successful model, goes up as you do this, the cost goes up, but also your understanding of your data has to improve. You will learn more about your data. You'll use awesome products that we have like Lilac and Apache Spark and notebooks, and you will interact with your data and get to know it like the back of your hand. You have to look at your data. You can't just go in and throw your data at the model, especially as you get to these later stages. The stakes are higher, you're putting in more data, and you will get more mature in terms of your understanding of your data processes. And each of these things, I think of this like going to the gym and lifting larger and larger weights. You don't just go and try to lift like the 300-pound barbell. You do work your way up, and you get stronger every day, and you get more prepared, and you learn the right technique and the right form. This is about evaluation maturity. As you work your way up here, you're going to max out your first evaluation benchmark really quickly, hopefully. And then you need a new one that is harder and pushes on all the weak spots. And then you'll need a harder one that pushes on even more weak spots. And you're going to need to do this iteratively. So you're going to have to mature in evaluation. And then even organizational readiness for AI. You want to get to a place where all of your stakeholders in your organization are ready to receive your model. If you pre-train a model from scratch immediately, folks may not be ready and may not know what to do with that. Getting a lot of proof of concepts and a lot of quick prototypes that people can get their hands dirty with, iterating quickly and learning what your internal customers need, that's really important too. So on all these things, again, this is why I recommend start small and work your way up. Even if you think pre-training is where you need to go, you still have all these other things. And I've gone through this over the past couple of years. I've had to improve my understanding of my data, and I do that every day. I didn't come into the world understanding all these big data sets and what to do with them. My team is getting better at evaluation every day. We're getting more ready to receive AI in our products at Databricks as well. This is my experience. And so really, you grow into these. But the other thing I'll say is we're here to support you. I still believe, and someone can correct me if I'm wrong, we're the only place in the world where you can start from one of these and work your way all the way up to pre-training your own model from scratch at GPT 3.5 Turbo and above quality. That's a really cool thing. I really love the idea that I can start with a customer, and I have started with customers a year ago when they're prompting GPT-4, and a year and a half later, we've pre-trained a model together. That's an incredible journey, and we can take you on that journey uniquely so. We have products that can do this, and there are different products for different stages because what you need from these and the amount of control you need is different as well. Okay, so what about the interaction? I look at this as kind of the inner loop. If you start with an off-the-shelf model, you then work your way through A, B, C, and D. You prompt, you might move to many-shot prompting, you might move to RAG or combinations thereof. Then you might move to fine-tuning and go back through these again. Fine-tuning might be enough that the model knows about your data and all you need to do is prompt it and you're done. That's great. That's an awesome solution. You may need to move to RAG, and RAG plus fine-tuning is a really powerful combination. Don't think that it's one versus the other. It may end up being both. I'd recommend you start with an off-the-shelf model in RAG first, and if that solves your problem, cool, you didn't have to fine-tune. You just saved a bunch of time and a bunch of money, and that's fantastic. If it doesn't, the next step is we might try fine-tuning, and if prompting doesn't work with that, we'll move up to many-shot prompting and RAG. So think of these as kind of you start with one and then you go A, B, C, D, you start with two and then you go A, B, C, D. Again, this is incredibly simplified, but for a broad audience, this is my general recommendation if I knew nothing about your use case and your situation. So I think of this as your outer dev loop and your inner dev loop. Now, here's another way to think about it. I want to go back to the Pareto curves. There's a reason I brought them up. I put a few more models on here. Again, these models were just chosen because they're kind of in different weight classes from being very small to very large. I could easily put the Mixtral models up here or the Mistral models up here or any number of other models, and they would fit on this curve very neatly, but I didn't have room on the slide, and you didn't want to see 30 models up here. This is our trade-off curve again. Here's how I think about this. That orange curve might be off-the-shelf models. Once you go and you fine-tune, you're actually moving to a different trade-off curve when you're serving that model. You now have a model that knows more about your data and your application. You are just in a different trade-off regime now. You go to continued pre-training, and as long as you're still getting ROI and you've got the data and you've got the maturity and you've got the evaluation, you've moved again to another curve. You have just improved your trade-off universally. You do this to any one model, and it'll probably be better than if you use the off-the-shelf model or the fine-tuned model. And then for pre-training, we're on another curve again. Now, your mileage may vary. You may end up running out of return on investment or running out of data or realizing you need to go back and get a better evaluation or realizing maybe your application is just solved. You can hit 100% accuracy on it. If that's the case, amazing. We don't need to even play this game. But this is how I think about it. And so it's kind of the same within this with prompting, many-shot, RAG, and combined. I shifted the curves a little bit because this will be different. The curves might be a little closer together. But these are all cartoon diagrams, but the same applies. By doing many-shot learning or RAG, you're probably going to have a better trade-off for any given model. And honestly, many-shot and RAG, I have it set up so you can switch the order in this slide because your mileage may vary and either one of these could end up being the right thing, and combining them may help as well. So remember before I said you have a fixed budget? This is why I love these Pareto curves. I have my fixed cost budget at inference time. How do I keep moving up? It might be that I graduate from doing prompting to RAG. And that's a way that I can stay within my inference budget, but I can get better quality. And I might go to many-shot, and I might be able to graduate into better quality while using the same model and having the same budget. So this is where you can start to really move up these curves. It would be the same thing for, if I'm building my own models. Going from something off the shelf to fine-tuning, now suddenly for that same inference budget, I can get a better model. I'm moving up this curve. I'm moving from the red line to the green or to the blue line, and then from the blue line to the yellow line. And then if I go all the way to full pre-training, if I pre-trained my own Llama 3 8B from scratch, and I've got the data and the maturity, I might be able to actually get a much better quality model for my budget. And this is one of the big reasons people do pre-train with us. They have some real-time application where there's just a huge constraint on how fast it has to be. And so you got to build your own model because something that's generic is going to be too big. And the same thing if we were in this world where we have a quality bar we need to hit and then we want to minimize cost. So on this curve, if you look at it, for GPT-4 quality, I might be able to instead do continued pre-training on Llama 3 8B. Llama 3 8B is a really fast, really cheap model to serve. That's the idea behind these curves. I know I'm throwing a lot at you very quickly, but this is what I love about these trade-off curves. Now again, these diagrams are cartoons. I won't promise you that you're going to get basically GPT-5 quality somewhere. This is meant to be illustrative, and I'm not going to promise you, all the usual disclosures. But this is the key idea. This is why you might pre-train, or why you might fine-tune, or why you might do RAG instead of prompting. Sometimes there's just a level of quality you can't get to, and sometimes it allows you new opportunities to trade off cost and quality in ways that will be a really good fit for your application. So I want to give you a few closing thoughts in the last couple minutes I have. First of all, in the outer loop, each step is much more expensive than the last. If you're fine-tuning, that is a lot more expensive than calling an API. If you're doing continued pre-training, it's a lot more expensive than fine-tuning, and so on and so forth up to full-on pre-training. What that means, though, and this is kind of, I want to guilt you a little bit, the cost of prompting an API compared to the cost of pre-training is so negligible that there's no reason you shouldn't go through every step of this ladder. It's going to take you a couple hours and cost you a few cents, compared to pre-training, which is going to take you a few months and cost you a lot more than that. So you have no excuse not to climb this ladder and go through every step of it. You should do that because each next step, especially in the outer loop, will dwarf the last step. So just do everything and work your way up because who knows, maybe you thought you needed to pre-train and it turns out fine-tuning and RAG solves everything. You're welcome, I just saved you a lot of money and a lot of time. And that's what we all like. There's no reason to skip steps. Now there are many more gradations here. We could talk about LoRa. LoRa is kind of in some sense a weaker, faster fine-tuning. We could talk about curriculum learning, which is a whole separate thing you'll hear about later today if you come to my talk on how we built DBRX. And the last thing I'll say, and this is kind of a heartfelt thing that I really truly mean because this is my experience, I think Databricks is the best place in the world to go on this journey. And there are a lot of reasons for that. But really, the number one thing for me, the personal reason I can say this, my day job is to climb this ladder. I have 35 people on my team, and their day job is to climb this ladder. My job is to break every single one of our products before you get the chance to do that, and then work with the teams to make sure they are wonderful to work with by the time you get there. And my job is also to be your partner. If you go on this journey and you get to some of these later steps, you're going to end up in a room with me personally or someone from my team. It's unavoidable because I want to make sure that if you're going to pre-train a model, it better be good for what you're putting into it. And that means I need to be there and chat with you about it. So that is my heartfelt message. Having come to Databricks almost exactly a year ago, I joined from Mosaic ML, which was my baby and my startup. I've been using all the Databricks products since then. We built DBRX using the Databricks suite of products, everything from Lilac all the way to MLflow for doing experiment tracking, and a lot of other tools in between, including some of the Mosaic AI products that we brought to the Databricks family. And I've been on this journey. I've been in your shoes. I am in your shoes every day. And my job is to make sure the experience is amazing for you. And this is how we built DBRX, and you can come to my talk later and hear about that. So in summary, very briefly, I love to end where I began. Number one, identify your measuring stick. You can't avoid this. Do it. Don't make it perfect from the start. This is an iterative back and forth between your measuring stick, building a model, realizing why your measuring stick is broken, and then making a new one. This is my everyday life these days. I can't tell you, a day that goes by where my team doesn't say, we need better evaluations. That is always true, but we should always be striving for better. Understand your constraints and costs. Know what your budget is. Know how that constrains you. Know your quality bar. Know what your non-negotiables are. And explore the design space from cheapest to most expensive and track ROI. And I'll just leave you with this ladder as we wrap up. Thank you so much. No, unfortunately, I don't think we have time for questions because I burned through all of my time. Correct me if I'm wrong. Awesome. So I will leave it to the next speaker. Thank you so much.